Why are fractals often confused with chaos theory? Imagine looking at a coastline from above. The jagged edges seem endlessly detailed, no matter how much you zoom in. That's a hint of what fractals are all about. They are shapes that repeat their patterns at every scale, creating intricate designs that seem to go on forever. You might think these shapes are just pretty pictures, but they are actually rooted in deep mathematical ideas. Now, chaos theory is another fascinating concept that deals with unpredictable systems. It explains how tiny differences at the start can lead to wildly different outcomes. Both ideas are connected because they deal with complexity and patterns, but they focus on different things. Fractals are geometric shapes with self-similarity. That means if you look at a small part of a fractal, it looks just like the whole shape. Think of a fern leaf or a snowflake. These natural objects follow fractal patterns. They are generated by simple mathematical rules that, when repeated over and over, produce complex images. Fractals also have fractional dimensions, which means they don't fit into regular shapes like lines or squares. Instead, they have a size that's somewhere in between. This makes fractals visually striking and mathematically interesting. Chaos theory, on the other hand, studies how systems change over time. It looks at how small differences in initial conditions can cause big changes later. This is called sensitive dependence on initial conditions. For example, whether patterns are chaotic because tiny changes in temperature or pressure can lead to very different weather outcomes. Chaos theory shows us that, even in systems that seem random, there are underlying rules and structures. It helps explain why predicting the weather or stock market is so difficult. The confusion between fractals and chaos theory happens because they often appear together. Fractals are the visual shapes that come from chaotic systems. For instance, the Mandelbrot set is a famous fractal that arises from equations linked to chaos. Many chaotic systems produce strange attractors, which are fractal shapes that show the long-term behavior of the system. So, when you see a fractal pattern, it might be a sign of underlying chaos. That's why people sometimes think fractals are the same as chaos, but they are really different ideas working hand in hand. In the world of numbers and nature, fractals show us how simple rules can create complex, beautiful patterns. Chaos theory reveals how unpredictable systems still follow certain rules, even when they seem random. Together, they help us understand the hidden order behind natural phenomena like clouds, mountains, and even our weather. Fractals give us the shape, and chaos explains how those shapes can emerge from unpredictable processes. Both ideas show that order and disorder are often two sides of the same coin in the universe of numbers.